For this problem, we're going to cool down a sample of gold. Let's parse the information. So we're putting a sample of gold into water, but we're focusing on the gold. The water is being used to absorb that heat. The mass is given, and the amount of heat transferred from the gold to the water is given. And we're given an initial temperature. So the gold is at 75.32 degrees Celsius, and then it cools down to some new final temperature. We're also given the specific heat capacity of solid gold. And a reminder, don't think of the specific heat capacity in that format. Think of it like this. Clearly separate your numerator and your denominator. So like in the previous problems and when I discussed the setup, I suggested that if you're given the specific heat, that you should focus on that and start your calculation with that. Don't necessarily worry about the formula. So here is the specific heat capacity of gold. Now, what's the problem asking for? If you scrub back, you'll see that we're looking for a final temperature. We're looking for temperature. This means we need degrees Celsius in our final units. So if you start with a specific heat capacity this way, you'll have your final units as 1 over degrees Celsius. That doesn't make any sense. What you need is temperature units in the numerator. So you take the reciprocal of the specific heat. And if you're not quite sure about this, you should go back and look at the formula and see that you are indeed dividing by specific heat, which is the same as multiplying by the reciprocal. Now I do my unit analysis. Multiply by the given heat value, so joules cancels. Divide by the given mass, so grams cancels. And our final answer, 11.9 degrees Celsius. 3 significant figures because of the 0.129 and the 87.6. So that's our final temperature. It's cooling down, so we're going from 75.32 to 11.9 degrees Celsius, right? Wait, hang on. That's not the final temperature. In the mathematical formula, it's change in temperature. What we've done is calculated the change, not the final temperature. Now, if you choose to do this using the formula, and you choose to solve for the final temperature, you have to be very careful about putting the right sign on the heat. But you don't have to worry about that if you don't want to, because the problem will tell you what to do. Let's go back and look at the given information. A sample of solid gold is put into cold water. Since the water is at a lower temperature than the gold, because of the way this was worded, that means the final temperature will be less than the initial temperature. So we take the delta T we just calculated and subtract it from the initial temperature to get the final temperature. And then just a rule on significant figures, since we're subtracting, we use the decimal place rule, which is why we end up with 63.4 degrees Celsius.